Hi everyone, so today we're going to be working on this problem. The rate constant for a particular second order reaction is 0.47 molarity to the negative 1 seconds to the negative 1. If the initial concentration of the reactant is 0.25 moles per liter, how long will it take in seconds for the concentration to decrease to 0.13 moles per liter? Now we're given this second order integrated rate law equation. So all we need to do is plug in what we know and rearrange to solve for time t. So we're given K. That's 0.47 molarity to the negative 1 seconds to the negative 1. And we're given the initial concentration. That's 0.25 moles per liter. Moles per liter is the same thing as molarity, so we're going to use molarity in this problem to make sure that the units cancel out properly. So this is the initial concentration, and that's what we were given, 0.25 molarity. And this is the concentration at time t. That's 0.13 molarity. So all we need to do is plug in these numbers and rearrange to solve for time. So 1 over the concentration at time t, that's 0.13 molarity, equals K, 0.47 molarity to the negative 1 seconds to the negative 1, multiplied by t, plus 1 over the initial concentration. That's 0.25 molarity. Now to isolate t, we're going to need to subtract 1 over 0.25 molarity from either side of the equal sign. Plug this into your calculator, you're going to get 48 over 13 molarity equals 0.47 molarity to the negative 1 seconds to the negative 1 times t. Now to get t alone, you're going to need to divide each side by 0.47 molarity to the negative 1 seconds to the negative 1. And when you do that, these units are going to cancel and seconds will be left on top. If you plug this into your calculator, you're going to get t equals 7.86 seconds, and rounding this to two significant figures, you're going to get t is approximately 7.9 seconds. So it's always important to remember when you're doing these kinds of problems to make sure that everything is in its proper units. For example, if you were given the rate constant in minutes and you needed to convert it to seconds, you'd have to do so accordingly, and vice versa.